Hi, I'm Jiwan Chong from Visual Learning Lab in Seoul National University. I'm going to present our paper, Transitional Adaptation of Pretrained Models for Visual Storytelling. This is joint work with Yeonjae Yu, Jiwan Chong, Hee-Sung Yoon, Jong-Seo Kim, and Gani Kim. I'll first explain our framework, Transitional Adaptation. In conventional caption generation, we combine pre-trained visual encoder with randomly initialized text generator to build captions with respect to visual contexts. Considering the recent success of pre-trained language models in text domain, it is natural to extend them to vision-to-language settings such as captioning. However, naively combining language models does not lead to improved caption quality. We believe domain mismatch is the culprit for this problem. Considering the vast gap between information stored in pre-trained visual encoder and pre-trained language generator, it will be difficult for them to work in harmony for another challenging objective of vision-to-language generation. Also, the target caption datasets are often too expensive to collect, and thus usually become too small to do with such semantic difference. To this end, we proposed welded models via a simple pretext adaptation objective. We divide the training process into 3 steps: pre-training, adaptation, and fine-tuning. First, the visual encoder and the language generator are pre-trained on the respective single-modal tasks. Second, the two models are harmonized via the adaptation task. Third, the adapted models are fine-tuned on the target task. Note that the adaptation step has lighter computation requirement and can be trained with relatively cheaper unpaired data. Now I'll introduce the sequential coherence loss, our adaptation loss for the visual storytelling tasks. Visual storytelling is a sequential extension to the caption generation tasks. It has to generate a more figurative and consistent narrative for consecutive images or videos. The sequential coherence loss enforces the text representation of a clip to well predict its past, current, and future representations. To compute the loss, we first process the visual and text inputs with the two models to get the respective representations. In the same manner, we obtain representations for each of the 5 clips in the video. To extract the past visual information, we first project the text representation with a linear layer. Then, we aim to increase the similarity between the visual representation of the past clip and the projection output. We use contrast flows to enforce this similarity. The other clips from the same video become the negative samples. We likewise formulate the current and future loss and denote the sum of the temporal losses as the sequential coherence loss. By predicting past, current, and future visual information, the text representation should be primed for generating captions with both visual specificity and sequential coherence. To harmonize the visual encoder with the language model, we use the output of the language model as the text representation in the adaptation step. Also, we experimentally show the importance of this technique. Furthermore, it is crucial to split between the adaptation training and the target task training steps. Note that we fix the generator weights during the adaptation step to prevent catastrophic forgetting of the text generation capability. We experimentally compared our TAPM with multiple baselines in both video and image storytelling tasks. We confirmed that our method outperforms baselines in both LSNDC and VIST, especially on SARDA score, which is designed to score human likeness. Since automatic metrics cannot entirely capture the concept of expressiveness and coherence, we conducted human evaluation for both LSNDC and VIST. In both tests, our approach shows preferable performance. To summarize, our method is the first attempt to demonstrate an auxiliary adaptation loss's effectiveness in welding a visual encoder with a pre-trained language model. Also, we propose the sequential coherence loss designed for adaptation in the visual storytelling tasks. Thank you for listening, and please check our paper to see a lot more details and experimental results.